Hey guys, welcome to this video. Thank you for tuning in. Before I talk about Trump's tariffs and its effect on the stock market, I'd like to first define some terms. The first is event analysis. So this is an event study. It's a tool from financial econometrics, and it basically measures the impact of a specific event. Now, originally, it's been used for earnings announcements and mergers, but we could use it for government policy, macroeconomic events. It's pretty diverse in its range in terms of what we can use it for. Now, the process begins by taking a data set, a historical time series data, and we define two key time periods. The first is the estimation window, which is a pre-event period used to estimate the normal return model. Now we're going to go a little bit, we'll see that in a couple of seconds, but basically it could range from whatever you want, okay? 120 days back, 21 days back relative to the event, okay? Um, the event window, which surrounds the event, is basically the days following the event and the days preceding the event, okay? Where the event date is actually set to zero, okay? Now, to estimate the normal return, we often use like something called a market model, which assumes that the return on the security I at time t is linearly related to the market return. Now, the market return is the S&P 500. For those familiar with regression, this should be somewhat simple to understand, okay? RIT here is the return on the firm, okay? Um, RMT is the return on the market, okay? Alpha and beta are firm-specific parameters, and EIT is the error term with mean zero, okay? That's a assumption in OLS that basically ensures that the parameters are not distorted, okay? It has to fit some kind of normal range, okay? Now, the parameters alpha and beta are estimated using the ordinary least squares, okay? So we've got these alpha hat and beta hat, and basically we want to minimize this this term right here, okay? Which is basically the goal. Now, once the parameters are estimated, we compute the abnormal return for each day in the event window as the difference between actual return and the expected return. Okay, so once we fit this to the data and we get these hats, we basically fit it into this to get the abnormal return. Now, to measure the total effect over a multi-day window, we compute the cumulative abnormal return over the event window tau 1 and tau 2. Okay, so this is the cumulative abnormal return. Okay, and in the graph, it'll be more pronounced using this to see the actual effect of the event, which we'll see shortly. To test whether the abnormal returns are statistically significant, we compute the test statistic under the null hypothesis of zero abnormal performance. Okay, and this is what we get. Okay, where sigma squared car is the variance of the cumulative abnormal return, and it's estimated from the residuals of the market model in the estimation window. Okay. This framework is not unique just to these circumstances, but it could be include multiple firms by averaging cross sections. So I mean, like if you're interested in a specific firm, we're not going to do that here. Using multi-factor models, Fama French. This is basically using counting ratios into your regression equation. So we could include like price book, price to equity. It's not as frequent as the daily returns. It's usually, I think, monthly or quarterly. So you have to kind of collect a lot of data in order for it to have some type of in order to gain some kind of significant type of inference. And then we could perform non-parametric tests or a bootstrap, and which we will try out a little bit later on. Now, Trump's tariff effects. Now we know what's going on kind of like in the headlines, basically where he's imposed like 100%, 125% tariff on China. And then you see the market reaction. And then yesterday, if you guys were tuning in, basically he put a hiatus on the tariffs for all countries besides China for about 90 days, and then the market jumped. Okay, so I mean that we couldn't predict whether he was going to do that, but after the tariffs, after he announced the tariffs, could we see kind of an effect afterwards of how the stock market would behave or particular stocks? Okay, um, in this case study, we're going to use data from when he was president last time. Okay, and he announced tariffs at that time. And there was an effect. Okay, there was an effect when he announced tariffs on the stock market at that time as well. And the two stocks that I'm going to be looking into comparing is Apple and Microsoft. Now we know that Apple supply chain, basically a lot of the electronics and some of the parts, it's from China. So this study actually kind of illustrates a really good point as to like how um, tariffs can affect. I mean, we could see the causal link uh, between, whose supply chains are dependent on China versus whose is not. And Microsoft, as far as I know, their most of their business is being conducted in the U.S. Okay, and that's the assumption. I mean, for those experts out there, if you care to enlighten or further clarify that statement, then I would really appreciate it. So here's the effect on Trump's tariffs effects, and it goes. I think the last date, which I'll show shortly, but we run this. Okay, we run all the packages that we need: Yahoo Finance, stats models, and Matplotlib and NumPy. And here I set parameters. Okay, and I kind of did it easy for myself. Um, okay, enter the event date. I put it all here as a kind of a way to look at it quickly. So this was the event date that Trump actually set tariffs last time. And then we enter the start date. I just put it whatever here. And then 2020. The event window, I'll put 200. And then I'll put 8. Okay, so I've got all these parameters, as you said, like we're talking about the estimation window a little bit earlier, the event window. So this is 8 days before and 8 days after the tariff. The start and end date. Okay, I mean, it's good to kind of pick at least a year or 2 years. I mean, I would say a year and a half, 2 years is fine. Year is fine as well. The bigger the window, say, for example, if you want to make it 20, 40, 80 days, I mean, like a couple of months, then you're probably going to want like a couple of years, okay, when you implement this. So, but like you need more data basically, okay, if you want larger windows. Now, what I do here is I basically load the data. As you could see, this Yahoo Finance, I basically set the parameters here. So it just carries everything that I inputted here. I mean, I've run this before. So for those familiar with Python, the reset index, not familiar with Python, the reset index basically flattens out the columns. So, the columns all could be seen pretty clearly. And then this percentage change is basically something that converts prices into returns. And you could see it here. Oh, and then also PD to date time, which is a useful pandas time series function. It converts the event date, which is, I think, I believe a string into a date. So that's a Python pandas trick that everybody should know. And yeah, we calculate the returns here. I call stock return stock return for Apple and Microsoft respectively. And the market return is the S&P 500. I'm not sure if people caught that. Yeah, the market ticker is the S&P 500 right here. You could use another market return. You know what? I should have put this here as well, but you could use another market return like the Nasdaq for example. That might be better. I mean, I've used the S&P 500 here, but the Nasdaq would work as well. Just as long as it makes sense. So, you know, I was doing some checks here. I mean, like I said, the reset index, it flattens these columns out here where date would have been here previously. And then I create an event window, okay, with this time delta function, okay, where you could basically conduct mathematical operations on it. So event date window before and then after. So I do that. Whoa, what happened? Okay, yeah, that was just a little bit of a syntax issue. But yeah, I mean, I basically calculate the event window here. If you're curious, the event window is, I said 8 days. But you could go into this and basically see where it's at. Um, yeah, so here it's the estimation window, which is going to be, there's going to be a Boolean true. The event window might be a little bit difficult to find because it's like 8. But in any case, the event window is there. I mean, you should see the Boolean as true. This is the good thing about Google collaboration. You could actually, you know, filter out if you really wanted to. Then we calculate the estimation window. Then the market return, we isolate that. I called it market return. Get the estimation window, we drop the NAs. We add a constant to X so that we have these ones. This is the intercept term, the alpha that we saw earlier. And then we model the stock returns with the OLS. And this model here is Apple, and this model 2 is Microsoft. The order matters the way I set it up. Now you could do multiple securities as well. You just have to add the parameters for those that are interested. Then I do the event window, and then I predict the event and get the expected return. And I do the same thing for Microsoft. Now I calculate the abnormal return, right, with the stock returns that we got earlier, and then the expected return that we just calculated from the regression. Okay. And then the cumulative abnormal return, we just take the cumulative sum. Oops. So we get the cumulative abnormal returns here for Apple and then for Microsoft, and then I plot it. Now you could see from this event that when last time it was May 10th, 2019, that Trump implemented tariffs, you could see how Apple precipitously declines. I mean, the price. I mean, you could just basically see it. It's very, very noticeable. Microsoft, there was not really an effect. It actually increased. Okay, so, you know, like using this kind of study, it's useful because you could kind of see what happened previously. Now, like what's going on right now, it's hard to say because we don't have a big enough window. Okay, I think his tariffs were implemented on the 5th of April, if I'm correct. So we should wait on it and see actually what happens. But if we were to like say devise a strategy, we kind of come up with the idea that, or we should, from this analysis, that Apple might not be a good bet, especially if there's huge tariffs on China. Now, like, I'm not sure if the magnitude of the tariffs has any effect on the magnitude of Apple's returns. That's something else that we can do, but we could statistically validate the fact that this event has a negative effect on Apple. And just for, I mean, if we do just a little bit of causal reasoning, we could come up with the conclusion that Apple supply chain is heavily dependent on China. Now we could actually conduct a statistical test as well to see if the decrease is legitimate for Apple. Okay, I'm just going to do with Apple here, but I mean, you run this, it's a t-test, one sample. We get the event data of the cumulative average return, 0 compared to 0, right? Because it's a hypothesis test. And then we get this t-stat and the p-value. And it's really significant, okay? It's a negative t-stat, and it's a statistically significant event, okay? We could use something like also a non-parametric test, which is the Wilcoxon test. And we could check that as well. Yeah, I mean, it's going to give you somewhat similar, or if not identical. So that's it for now. Thank you very much. I hope you learned something. And this is actually a great method of testing specific events. It's not just restricted to policy announcements, but it's also useful for earnings announcements. Um, you know, say if you're running a marketing analytics campaign and you want to see the effect of a discount, you could use that day and then analyze the sales at pre and post to see if there's any statistically significant effect. So there's a lot of use cases. I hope you enjoyed this video. Click subscribe if you're interested for learning more. Thank you very much and have a good day.